Hello, everyone. I'm Product Manager Naomi Lai from DFI SOM team. Thanks for joining DFI webinar. Today's topic is, how does DFI embedded computer endure for harsh environment with EHL 982? Let's go started. Here is agenda for today. What are System-on-Modules? System-on-Module design. EHL 982 future highlight. Rugged design for harsh environment. What are System-on-Modules? High integrated component for embedded processing. You can easy to combine module and carrier board via standard connector. Let's go to the details. SOM are designed to industry standard and provide clear design guidelines, support a secure roadmap for future design. You can spend design time developing customer-specific needs on the carrier board. SOM contains the CPU, memory, storage, I/O, and the COM Express board, support software package, and the OS support, involve Windows and Linux. SOM has standard footprint and the interfacing connectors. It can easier to connect its COM Express board and the carrier board. Design smart with SOM's component, manage fuel component, and the simplified sourcing and lifecycle management. Carrier board combines with System-on-Module based on current and future CPU, save your development time and money. Reliability by design, dependable in extreme temperatures, shock, and the vibration test. To meet your technical requirement, you should consider multiple factors, such as SOM can accelerate time to market, focus on development of application-specific part of product, optimize product development and project cost, access to latest technology, stand out from competition by using SOM based on advanced technology source from the market leaders. You may read on for more about how DFI addresses this requirement. In recent years, we've started to develop SOM product line. SOM divided two blocks. One is small module Qseven, another is powerful module COM Express. There is a new form factor, COM HPC now on. COM HPC specification extend to COM Express, not to replace it. Qseven is equipped with fast serial interface in an ultra small form factor. It much smaller than other SOM, which make it an ideal solution for space limited and low power applications. DFI provides reliable System-on-Modules that include COM Express Mini, Compact, and Basic, based on Intel, AMD, and the NXP SoC. In addition, DFI can do fast customization for various embedded computing solutions. Computing technology is advancing at incredible pace, pressuring DFI to find a way for stay competitive. For a company developing high-end and entry-level product, this challenge is even greater due to the need to incorporate a wider range of technology. DFI SOM product plan follow up Intel, AMD, and the NXP SoC, supercharge our product roadmap and increase stakeholders. The world is getting smarter and more connected, which means more computing power is being placed into smaller devices. What used to be confined to desktop computers is now available in your pocket, thanks to SOM platforms. If you want to use one of these modules in embedded system design, you'll need to design or buy a cluster carrier board to support your module. Next, I will provide a glance into SOM design. The SOM form factor defines mini, compact, and basic modules. SOM is following PICMG standard design that includes DisplayPort, PCIe, USB 3, and GPIO. Type 7 pinout was generated to server class application. It's up to 410 gigabit Ethernet and up to 32 PCIe lanes without any video and audio interface. Type 6 modules include PCIe Gen 2 lanes, USB 3, DisplayPort or HDMI output, and the PEG port. Type 10 is mini size, only use A and B boot-to-board connector. It reserves spare pins for SATA and PCIe, uses a second LVDS, has VGA. Qseven provides gigabit Ethernet with RJ45 connector and USB OTG. Also provide multiple digital I/O, up to 24 LVDS pairs. SOM can meet all performance requirements. The module supports a wide range of performance, from NSP to Intel processor. The SOM standard is well established and already prepared for the future. SOM is a computing solution that consists of the application hardware and software for any embedded product. In terms of software, it contains operating system, device drivers, and BSP. To enhance between module and the carrier board, several common single configurations have been defined to ease system integration. There are only single 220 pins connector in Type 10, Type 6, and 7, up to 414 pins connector. Qseven uses a flexible MXM slot. The difference between the modules is the overall physical size and the performance available supported by each. Modules should be equipped with a heat spreader. It provides a common interface between modules and the thermal solution. Figure shows module and the heat spreader assembly to a carrier board. You can choose 5 or 8 mm stack height. The overall assembly height increased from 18 to 21 mm. About the thermal solution, with the standard heat spreader, we can attach semi-heatsink or semi-cooler on top of heat spreader, become a complete standard thermal solution. DFI can provide standard cooler or customized thermal solution to meet your requirement. After SOM introduction, I'm going to introduce EHL 982 of Type 10. EHL 982 using Intel X6000 series SoC. Intel has developed a new line of processors enhanced for IoT. This build a new level of CPU and graphic performance with IoT features like real-time, security, and so on. For this slide, we can know the new SoC deliver 1.7 times improvement in single-thread performance and up to 2 times performance improvement in graphic. EHL 982 have faster transfer with PCIe Gen 3, support 16 gigabit low-power DDR4 onboard memory, up to 3,200 MHz. Network transfer in real time. Upgrade faster 2.5 GHz. EHL 982 is also available in wide temperature and low power, making them a perfect match for mission-critical fanless edge computing applications. If you would like to learn more about EHL 982, you can scan the QR code for datasheet download. DFI SOM often work in the most demanding environment, so we design them to meet the highest standards of quality and reliability. The next page will show some of our efforts to guarantee this. Dependable in extreme temperatures, and the test to work from -14 to 85 degrees. Reliability design to run for many years, and the 24 months warranty for all SOM. Our product enhance security, support onboard TPM, secure boot, and the frozen BIOS. For environmental engineering, have water, shutter, and the job proof. SOM are designed with wide temperature required for industrial automation. DFI conducts thermal testing for each product during the production process to reduce fail rate during operation in extreme environmental conditions. Modules need to be able to operate not only in extreme temperatures, but also across a wide range of voltage. Unstable, incorrect or transient supply voltages may cause a system shutdown. For rugged application, SOM with conformal coating service to avoid damaging electronic component. Increased urbanization is an unstoppable worldwide trend that drives change in the transportation sector. With a growing level of environmental awareness and the cost consciousness, the stability and the ease of maintenance of transportation systems have become critical issues for system integrators. DFI SOM is able to overcome these challenges by combining upgradable designs with lifecycle management in the 5G era. To learn more about DFI, you could kindly scan the QR code for more information about DFI product and the success stories. At the end of today's presentation, we would like to request your valuable feedback. Please scan the QR code and complete the survey. You will have a chance to win one of the $25 iTunes Apple Cards. That is all for the presentation for today's webinar. Please don't hesitate to visit our website for more product details. You could scan QR code and leave us an inquiry. We will reply to you as soon as possible. Thank you for spending your time with us today, and we hope to see you next time.